We've already taken a look at linear equations and some of its applications. We've also looked at quadratic equations and some of its applications. Now we're going to investigate other types of equations in section 1.6. We have a couple of examples to practice with here. We have 6x cubed plus 54x squared plus 120x equals 0. This is a polynomial of degree 3 on the left-hand side of the equation, but with a little bit of factoring, we might be able to handle this one just fine. If we take a look at the left-hand side here, think about the greatest common factor of all three of those terms, and you'll see that it is 6 times x. If we write the rest of the factor form, we have 6x times x squared plus 9x plus 20 equals 0. Now the trinomial in parentheses is factorable, so let's continue breaking down that left-hand side. We can write this as 6x times x plus 4 times x plus 5. Using the zero product rule, the only way to get 0 by multiplying is if we multiply by 0 somewhere along the way. We're going to set each one of the factors equal to 0. Either 6x is 0, or x plus 4 is 0, or x plus 5 is 0. We have three solutions to this equation, therefore. Either x is 0, or x is negative 4, or x is negative 5. Three solutions for a cubic trinomial on the left makes perfect sense. Let's take a look at our second example. We have x cubed plus 2x squared minus x equals 2. We don't want the 2 on the right-hand side. We want to leave that right-hand side clear. So let's start by subtracting 2 from both sides. So we'll have x cubed plus 2x squared minus x minus 2 equals 0. In your previous classes, you may have been told that whenever you're trying to factor a polynomial with 4 unlike terms, you can try a technique called factoring by grouping. We're going to form two groups of 2 terms each, and we're going to factor out the greatest common factor. For x cubed plus 2x squared, the greatest common factor is x squared. So we'll write the first 2 terms as x squared times x plus 2. For the second group of 2 terms, we have negative x minus 2. Really, the greatest common factor here is 1, but we'll go ahead and factor out a negative 1. And we'll rewrite this as negative 1 times x to get the negative x, and negative 1 times positive 2 to get the negative 2. Now we have 2 terms instead of 4, and there is a common factor in these 2 terms, and that is the x plus 2 factor. So now we'll treat this as our new greatest common factor, and we'll say that x plus 2 has to be multiplied by x squared and by a negative 1. Now we can use the zero product property to say that one of these factors must equal 0 itself. So either x plus 2 is equal to 0, which would give us that x is negative 2, or we would have that x squared minus 1 is equal to 0, which would give us that x squared is equal to 1, or using the square root property, x is equal to the positive or the negative square root of 1. So x is either equal to negative 1 or x is equal to positive 1. That means we have 3 solutions as well. Either x is negative 2 or x is negative 1 or x is positive 1. Again, because we started with a cubic polynomial, this makes sense.